Now we'll take a little better look at the CPUs and cooling systems that we use. That includes the sockets, some of the Intel AMD ones. We'll talk about the idea of what cache is for the CPU. We'll also then talk about the different types of cooling systems and some of the cooling system selection factors and as well as CPU selection factors that you want to take into consideration when you're making your purchase. When we talk about CPU sockets, as you can just see visually, that different types of factors of sockets exist. In fact, about the only thing that any of these sockets have in common is this ZIF lever. Zero insertion force is what it stood for. That helped you in being able to basically seat the processor in or to push this processor out of the socket so that you could replace it. But because of the different types of sockets, that leads us to knowing that there's different types of form factors for the CPUs. And again, remember, the sockets are designed to fit with the CPUs. So if Intel or AMD come out with a new type of CPU, maybe a faster one, a new maybe 8-core CPU, well, all right, we need to make sure we have a socket where it'll fit into the motherboard. Now, Intel has a number of different chipsets, I guess is what we'd actually call it. Basically, they all fall in the idea of a grid array. As you can tell, right, I have a series of pins going both horizontally and vertically in a sometimes a square fashion. That's the grid array that they're talking about. The one that you see here, the first one, the LGA 775, is called sometimes a socket T, and it's a land grid array, by the way, LGA, and it gets the number 775 by having that many copper pins with no socket holes to attach to the motherboard's pins. So in this case, we use a load plate to be able to connect the CPU. And then, of course, with most of these CPUs, we'll talk later about having a way of dissipating the heat off of there. The LGA 1155, also referred to as socket H2. And by the way, this is important because when you're going to purchase an actual CPU, one of the questions that the salespeople probably will ask you is, what socket type do you have on your motherboard? Now, and again, you're getting the idea that the numbers here are representing the number of pins. So the LGA 1156, again, is also sometimes referred to as socket H. And again, it's one that's commonly used in consumer desktop computers. It was good for the Core i3, i5, i7, Xeon, Celeron, Pentium processors. So that's a pretty long list to talk about. The other one, the LGA 1366 here, is known as the socket B. And again, of course, you're seeing as the number of pins grow, that means generally the CPU is going to also be growing. The LGA 2011 here is called socket R. And again, was designed as a replacement for the 1366. And it's usually the type that you'd see on the higher-end desktop computers and servers. And again, designed for the different types of processors that Intel comes out with. Now, AMD has, of course, its own chips that is the competition to Intel, and a number of different types of sockets as well. The first one, the AMD 940, is primarily used for 64-bit servers. Most often you see it with the Opteron or the Athlon 64FX processors. The AMD2 that you see here, this one is similar to the 940. With the exception that it uses the DDR2 controller instead of DDR that's used by the 940. And it was designed, of course, by having that number 2, you would think, as a replacement. The AMD 2 Plus is designed to replace the AM2, and they are, again, similar in design as far as the type of processor they can support. You'll also notice, again, that they all have that ZIF arm, or most of them do. The AMD 3 that you see over here is again designed to replace the 2 Plus, but it's not compatible with the previous versions of the AM2 or the AMD 2 Plus because the pin layout is slightly different, and this one actually has like just one more extra pin. The AMD 3 Plus that is sometimes called the AMD 3B was designed to be more efficient, use less power. The FM1 is AMD's next generation socket type. designed to be used with the Fusion and Athlon 2 processors. And then, of course, we have this F1, which is an older model socket type that was designed just for the Operaton and Athlon 64FX processors. Now, when we talk about cache built into the CPU, cache memory is a specific type of very fast memory, by the way, that the CPU can use for processing the data and the instructions of how to deal with the data. Now, obviously, if we think about the CPU normally communicates, as I said, through the bus to memory. Well, the bus speeds are incredible, but there still is a path to take. And we do measure in microseconds how quickly we can retrieve information off of memory, but it still is slower than if I went into the actual cache. In fact, there was a time when the RAM memory would talk about having a 70 millisecond access time. And I know that might sound like a really fast time, but today we're measuring them in 1 millisecond of time, just because of the improvements of memory. But at the time, when we were using that slower memory, we were measuring, in the 1 milliseconds for access to cache. So cache was even more important at that point. Anyway, there's two types of cache. The L1 cache is built into the processor. And so some of what you might pay for is how much cache is on board that chip, because the more that it has available to it, the faster this processor is going to be able to execute its own instructions. And then right next to, usually on a separate bus, not the same system bus that we'd use to get to memory, on that local bus we would then be able to have access to the layer 2 cache. L2 cache is what we call it when it's not attached to the CPU, but it's there only for the CPU. Now, some of the other characteristics for the CPU, obviously the architecture. It's basically it talks about the width of the front side bus. CPU's front side bus is either 32 or 64 bits. Obviously, in today's world, almost all of them will be 64 bits. Clock speed that we talk about is how many cycles, basically how many instructions that it can perform in a given second, and that's where we start measuring the speed in the megahertz. Overclocking is something that we used to try to do on the system board to get it to run at a speed faster than the CPU is rated to handle. But if you did that, you could cause the CPU to overheat. So again, which could cause damage. It's never a great recommendation. The CPU speed is just kind of an overall term that talks again, like the clock speed, about how many instructions per second we can run. Throttling is used sometimes to adjust the speed of the CPU. That's basically throttling is a way to slow down the machine during idle times. That's great to be able to conserve power. So that's kind of a power saving feature, especially good for the laptops. Hyper-threading is a feature of some of the Intel chips that makes one CPU appear as though it's two CPUs. It uses extra registers to overlap the instructions. So, basically sometimes trying to get a 30% boost in what it can do. When we talk about threads, a thread is like an instruction. And so if I can manage to handle two instructions at a time, that's where it gets me to think that it looks like I have two processors. And that's what hyper-threading was. It's not the same as having multiple cores. The integration of the graphic processing unit is something that we can have as a part of not using the chip or purchasing the chip to handle graphic instructions rather than sending it off to a dedicated graphics card. Virtualization support is very important. Most of these are compatible, but that's a question you want to ask. Is it compatible for virtualization? Because that's where we use the hypervisor, which is a concept of emulating hardware for virtual machines, and uses it to help connect to the actual hardware. The number of cores is the thing that's really cool, of course. That means that we actually are building in multiple CPUs within one chip, and that's where we can, and that is different than hyper-threading. That's not a virtualized type of core. That's an actual core. So some of the options, of course, we usually talk about dual core, having two, or quad core. And now remember, if you have a board you can certainly buy, even for the home use, a board that has 2 sockets. And in that case, you could put a CPU in each one. And if each one were a quad core, 4 cores, then you would have, in essence, 8 cores or 8 processors on that one system board. And as long as you have an operating system that can work with all 8, and you have programs that can take advantage of those 8, then you would have what I would think is a screaming fast system. But talk to me again in 5 years, and I'll probably tell you, oh, that's old technology. Cache, again, like I said, is the dedicated speed for the CPU, or not speed, but the memory for the CPU. The voltage regulator module is a replaceable one, and that's designed to regulate the voltage to the CPU. And then MMX is something that started out a long time ago with Intel when they started first introducing their Pentium chips back in the late 90s, I do believe. And the multimedia extensions is what it stands for, and it was basically extra instructions. We called those instructions microcode that were designed to help enhance the ability to work with sound, video, and graphic multimedia functions. Now, as you're getting ready to buy a CPU, remember, you got to check to make sure it's compatible with the components of the system, that it fits the design and form factors of the motherboard, and you also want to make sure you understand the pros and cons, because there will be several different types of chips you could buy that could fit the same socket, but you basically want to know what's the reason why I'm going to choose one over the other. Could it be speed, performance, or price? Now, when it comes to the cooling systems, again, the idea is we want to be able to pull the heat out or cool off the chip that is running the CPU. One of the obvious ways is to put a fan either next to or on top of that CPU. Obviously, venting is an important aspect. Many of the CPUs will have a heat sink, and again, the heat sink is designed to pull the heat off of the processor, and then usually a fan would sit on top of that to basically move the heat off of the heat sink. Also, there's some liquid-based or thermal-based options that we look at, but the liquid-based is a liquid-based cooling system that would have to constantly cycle liquid through, which is kind of the same idea of your car, isn't it, with a radiator. We keep cycling it through to keep it cooled off. Now, as you're talking about the cooling system selections, of course, we could be getting fans also for other types of objects that need to be cooled off, but since we've mostly talked about processors, that's what we're thinking of. But again, you have to ask the question, what needs to be cooled? Will this cooling system fit in the case? Will you need multiple systems for cooling? And what size of fan do you need? But remember, this is also going to have to be a part of the discussion for how are you going to power this fan.
On the back of this computer, we can see 2 fans, or better yet, you could probably see one, and I have to imply the other one is there. This right here is the fan that's going to keep your entire tower cool. In fact, on the other side of it is where the CPU is housed, so it's really important that not only do we have great circulation in the back of the computer, so these aren't blocked, but you realize the circulation will go in here and also aid in keeping your processor cool as well. Down here is the power supply. And we know that, of course, because we have everywhere to plug in electricity. But you'll see here this is vented as well, because power supplies can heat up to a great degree. And built inside of that power supply is actually an additional fan. So in this computer alone, we have 3 fans to keep it cool. Sometimes you'll see 1 or 2. Sometimes there'll be a giant fan. A well-built box will probably have 2 or 3 to make sure that this is running optimally. Again, you always need to make sure wherever you put this tower unit or the desktop unit that you're not blocking the back of the machine, because it will definitely have a meltdown.